What's up, folks? Welcome to Math with Mr. Weeb. Today we're looking at evaluating algebraic expressions in our Lesson 2 Your Turn questions. Let's see what those questions are. Here it says, what is the value of each expression when t equals 4? So first, what we're going to do is rewrite each of these. This is this underneath it usually, if we have room. If not, we can go up to another line. I'll show you what I mean. So here we're just substituting a t with a 4, subtract 8. We do one step at a time. We do BEDMAS. Multiplication comes first, so we've got 12 minus 8, and the whole thing equals 4. And there's our answer. Next, we have 4t plus 5 times 2t minus 3. Let's go through it. Let's first substitute all the t's with a 4. So this is the same as 4 times 4 plus 5 times 2 times 4 minus 3. Next, we need to go through this BEDMAS style. So I'm going to leave everything outside of the brackets all alone. I'm just going to solve what's inside the brackets. Here we have 8, right? That comes first because we have multiplication there. 8 minus 3. Now I don't have any more room to go underneath, but I'm going to start it on a new line. Now I still have things inside the brackets, so I will keep just copying it along. 4 times 4 plus 5 times 5. Now I'm going to put another equal sign, and I'm going to go, I'm going to do all of the multiplication, but in order. So 4 times 4 is 16 plus 25. Finally, if I add the 10s, I've got 30. If I add the 1s, I've got 11. So 30 and 11 is going to be 41, and that's my answer for that. For number 2, it says, when x equals 10, an expression has a value of 50. What could the expression be? We need two different possibilities. Okay, so x equals 10. The first one I can think of is I've got some number times 10, and I know it has to have a value of 50. Well, what times 10 is 50? I could have 5 times 10, and that would be 50, right? So that means 5x would have a value of 50 if x equals 10, when x is 10. Not done yet because we need two possibilities. So what if we added something as well? What if we had something times 10 plus something else and have that whole thing equals 50? Okay, let's choose something to multiply by 10 first. Let's say that we had 3 times 10. So in this first box would be 3. Well, that would give us 30, right? And we know that we need to get to 50, so I need to add 20 more. So inside this box, I would say 20, and the whole thing would be 50. So our final expression would be 3x plus 20. And that is it. Remember, read carefully. It says we need an expression. That means no equal signs, right? This is a good expression. This is a good expression because there's no equal signs, even though we know the value of it, right? But the only reason we know the value of it is because we know that in each of these cases, x is 10. Let's look at the next question. It says, the rule for a pattern is that term n has the value of 6n. What is the pattern? Now solving this takes us right back almost to the beginning of the year, where we did a whole bunch of patterns, and you might remember us making a bunch of these types of T patterns where this was the term number on the left, and it was also often called n, and the term value was in the column on the right. And this was, in this case, the term value here is going to be 6n. So this is 6n. So basically when we had a 1, a 2, a 3, a 4, basically we can take this n and substitute it here. So 6 times 1 gives us the value for the first case. So that gives us a 6. For the second case, it goes 6 times the second value, right? 6 times 2, so that gives us 12. Then we have 6 times 3, which is 18, and 6 times 4, which is 24, and it would keep going. So the pattern here is going to be 6, 12, 18, 24, etc. There is our pattern. How can you figure out the 100th term in the pattern? Well, you could pretend that this chart kept going. So it went on and on and on until it got to 100. Not 106, but 100. So how did we figure that out? Well, we did the same thing. Instead of inserting 4 as this n, now we insert 100 as this n. We replace this n with 100. So 6 times 100 would be 600. And I might explain it like this. Substitute the n in the pattern rule with 100. Next it asks us, which expression is worth more than 400 when n equals 30? Well, we can just solve this like this. So this becomes 10 times 30 minus 20, which becomes 10 times 30, which is 300, minus 20, which equals 280. So that's not more than 400. The next one, we can substitute the n, 5 times 30. Okay, 5 times 30 is going to be, oh, and then we're adding 200. That's going to give us 150 plus 200, which is equal to 350. That's also not more than 400. Let's do this one. N is going to be 30 still, plus 200, which gives us 230. Not more than 400. That means it has to be this last one, but we may as well solve it anyway. 15 times 30 plus 8. And let's see, that's 450 plus 8, which is 458. And that is the only one that is worth more than 400. How much more or less is this expression worth when x equals 20 than when x equals 10? So let's solve this 2 different times. I'm going to solve it first in blue. So I'm going to substitute the x with a 20. Here we have 20 minus 2 in brackets and then minus 5. Okay, now we write it again underneath it. And we're going to do brackets first, right? According to BEDMAS. 3 times 18 minus 5. Now we have to do the multiplication here. 3 times 10 is 30. 3 times 8 is 24. So that would be 54. So we have 54 minus 5. And the whole thing is going to be worth 49 when x is 10. In red, I'm going to have x equal 10. So I'm going to write the whole thing again. 3 times x minus 2 minus 5. And now I'm going to substitute the x with a 10. 3 times 10 minus 2 minus 5. So here we have, in brackets, 3 times 8 minus 5. Notice I'm going one step at a time. 3 times 8 is 24. Minus 5, which equals 19. So that was the final for that, and 49 was the final for this. Now I have to go back and check to see, have I actually answered the question? It says, how much more or less is this expression worth when x equals 20 than when x equals 10? So it's saying, how much more is this than this? So to figure that out, I have to find a difference, right? To find out how much more this is than this, and finding a difference means I have to subtract. So I'm going to take 49 minus 19, and I will come up with 30. So there's a difference of 30. And I would answer it in a full question, since this is a word problem, like this. The expression is worth 30 more when x equals 20 than when x equals 10. That's it for today. Thanks for watching.